you guys can either chat the answer, or you can come off a mic and answer. And I want you to practice it this way. This is where I like to go. If there's been enough talk about the same thing, I want you guys to be able to now practice it. And it sounds like we have issues still independently. So let's practice it together, which hopefully will help independent practice. So I'll read it. 16% of all Americans suffer from sleep apnea. A researcher suspects that a higher percentage of those who live in the inner city have sleep apnea. Of the 340 people from the inner city surveyed, 73 of them suffered from sleep apnea. What can be concluded at the level of significance of alpha equals 0.1? You guys tell me, are we doing a hypothesis test here? Is there a question? Is there a claim? You know, are we doing an interval? I'm just kind of bringing up 2 weeks ago too, just for the heck of it.
First of all, I see that there says higher percentage, so that should be a red flag, right?
Yes, and that is going to help me determine my alternative hypothesis. I want to determine if it's about P or if it's about mu, though. Is it about a mean? Is it about a proportion? I boxed it. Proportion. Oh, am I? Yeah, there it is. Proportion, because we're talking about a percentage, right? So this is P. And she said higher, which means more than. More than what? What number? What number am I comparing it to? 16%. Is it higher than this for all Americans? Is P greater than 16%, so 0.16? So good, we got the alternative hypothesis. Actually, while I'm at it, what kind of test is it? Is it left, right, two-tailed, which one?
Right.
Right.
Right-tailed, because it's pointing to the right. It's greater than. It's a right-tailed test. Now that's going to tell me the location of the rejection region. That's going to tell me the location of the test statistic. That'll tell me the location of the p-value. All that is in the right tail. What's my null hypothesis? What goes here?
Equal.
Mm-hmm.
Equal.
Yep, and I'm not changing the value. It's still 0.16. That's the value I'm comparing everything to. But now, I want you to tell me what the hell. I'm gonna say, what the hell does this mean? P greater than 0.16. What does it mean in words? Well, what is P? P is?
You just want it translated, so population is greater. So if the alternative is correct, the population will be greater than 16% suffering from sleep apnea.
Yes, I'm gonna be a little more detailed. If I'm rejecting this, what does this mean? This is the percentage or the proportion, population proportion or population percent of those who live in inner city. So the, I'll say the percentage from population of inner city people, right? I'll say people, is more than 16%. So yes, you are correct. I was just a little more detailed because this over here is talking about basic all Americans, and this over here that we're running the test about is talking specifically about inner city. We want to determine if the inner city makes sleep apnea better or worse. Basically worse, right? Because it would be bigger in the inner city, which I'm assuming is probably true. That's my assumption. But like she said, if I'm rejecting the null, then I can support that and say that, yeah, the inner city is going to make sleep apnea worse, according to this. All right, cool. Of the 347 people from the inner city survey, so what is this now?
For N.
That's the sample. So we're taking stuff from a sample now, right? We want to determine something for a population of inner city people. So we're taking a sample of them. 73 of them from this sample suffer from sleep apnea. So what's that?
Next.
My X is 73, yeah. So let me ask you this. Well, P hat, what would this represent, this P hat here? If I were to calculate it, right? 73 out of 347. 73 out of 347 is whatever it is, 0.2104. 0.2104, right? This is my X over N. What does that represent? Sample proportion, yeah. That is the proportion from the sample of people of inner city that had sleep apnea. 21% from the sample that was taken from the inner city or whatever inner cities were surveyed, 21% of that had sleep apnea. So in the sample, more than 16% had sleep apnea. So I'm assuming that we might be supporting the alternative, but we'll see. Now they asked for test statistic, P. Let's go and how do we find the test statistic? I'm asked for the test statistic. How do I find that? Oh, I'm sorry. What can be concluded at the level? So alpha is 0.10, right? Right. So the test statistic is a z-score. Where do I get it from? If I want a test statistic or I want a p-value, you could always refer back to this if you need to. I don't know if I make this as bright as I should. Gives test statistic and p-value. All the stuff in this column gives the test statistic and p-value. All the stuff in this column gives the critical value. So what do I do? Which one am I using? 1 or 2A or B? Which one? Let me get rid of this. Which situation am I using? I'll get rid of this because you put it all. Yeah, okay. 1, I'm doing the proportion. So if I want to find the test statistic or the p-value, then I'm going to do 1 prop z test, right? That's going to give the test statistic and the p-value. So let's go back here. Let's go to my calculator. And I want 1 prop z test. So everything, you know, with test goes stat, scroll over to test. 1 prop z test for me, number 5. And then, all right, cool. So now I'm here. What's the P0 thing?
.16.
Yep. And where do I get that from? Over here. It just so happens to be the same as the last example. So I already have 0.16 in there. That's not always going to be the same. I mean, X, you guys told me it was 73. And you guys told me it was 347. And then, you know, what do I do here? How do I know which one of these is my situation? Do I do this one, or this one? I have 3 choices. Yep. I'm looking at the chat too. Greater than, so it's right-tailed. I need to make sure that this one over here is highlighted. You see how I moved it over there? Sometimes I think some of you may think you're moving it, but you're not. And then you're getting p-values that are wrong. Because depending on whether it's a 1-tailed or 2-tailed test, that can change your p-value. So this is matching my alternative, p, and then greater than. See, this is saying proportion greater than the claim value, which you stated was 0.16. Do I care about color? No. Do I need to draw it? No. Actually, I've never put this up for you guys. It's showing you, right? It's showing you this. And actually, does this give you, this might be another way. No, this is giving you the test statistic and the p-value. So this is another way to do it and draw it if you want to see it. You see the area in the right tail? You don't have to draw it though. That's just, I never actually showed you what that looks like. But if you want the values, you can go that route or go this route. Actually, I'll put both of these on here just for notes. Just for notes if you want it. So this is your output in terms of calculations. If you want to see it, it'll draw it, give you the same test statistic and p-value. Calculate, draw. This is what it looks like, which is easy to do that by hand. You know what I'm saying? But if you wanted to do that for you, this is what it looks like. You can see that, I mean, it's a very small area in the right tail, but right, either one works. And again, let me write this out. The first thing here is my alternative, my test statistic, my p-value. So you guys, I mean, we did a little more than we needed to, but it asked you for the test statistic. So what are you going to tell it? Your test statistic is a z-score equal to approximately what? Yes, saying test statistic E is, and then you have to pick whether it's Z or T. So because it's a proportion, it's always Z, and it's equal to, please show your answer to 3 decimal places. So it's given to me here, 2.55, and now how do I round that? What do I put? 2 point what?
56.
Yeah, 2.56, which technically is rounding to 3 because I can't go 9 to 10, so I got to go 5 to 6. Now, the next thing it's asking me for is the p-value. Please show your answer to 4 decimal places, and this gave me that too. What's my p-value rounded to 4 decimal places? Yep, 0.0052. 0 point, make sure you check the amount of zeros, yeah, because that'll change your conclusion or potentially change it. All right, cool. So we have the test statistic, we input that, p-value, we input that. Then it says p-value is blank alpha. P-value is blank alpha. And it has a drop down of less than or equal to or greater than. My alpha, I could bring that down, was 0.10. Which one's bigger? You know how I with the greater than or less than, it eats the bigger number or it points to the smaller number. So which one's bigger, alpha or p-value?
Less than.
Awesome. So it points to the smaller. Cool. And typically, you know, because the p-value method states, where is it? If p-value is less than or equal to, then we reject. So that's why the drop down includes less than or equal to, okay? Technically, it's not equal to, but it is quote unquote less than or equal to alpha, which means that so now it says based on this, we would blank either reject, accept, or fail to reject. We never say accept the null hypothesis, technically. Reject, accept, or fail to reject. What am I doing based on the fact that p-value is less than alpha? All right, so cool, I forgot. Where's my p-value method?
You reject.
We reject, right? P-value is smaller than alpha, we reject. I don't know why all of these are rejections. We're rejecting the null. So actually in our own words or your own words, what does that mean then? You know, you're rejecting the null. What does that mean to you? And I'm going to quote you. But I think this will help anyway. What does it mean? I'm rejecting the null. What do I do? What is that telling me? If I need to go back here and look at what the problem said. However you, go ahead. Try. It doesn't matter if you're wrong.
So the inner city people, the incidence of sleep apnea is higher than 16%?
Yep. 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 Statistically speaking, we can support, right? We can say that there is sufficient evidence, or we can support. So it's statistically significant to say, right? Because we can't conclude, you know, you're gonna hear statisticians almost like a lot of BS happening, because it's like we're not really stating anything true, like completely, because there's potential of error. But we said that there is sufficient evidence, or it's statistically significant to support what she just said, to support the claim that there is, or we should say, the percentage, I'm gonna say percentage, see, this is me wording it, of people in inner cities have have a proportion of sleep apnea greater than 16%, which is kind of what she said, but I can't remember what she said exactly, but that's kind of what she said, right? Now, I want you guys to choose, and let me copy and paste this. This is what they have as your options. Hold on. Did it go through? No, go through. Okay, hold on. Let me copy and paste. Hold on. I'm waiting. Thank you. This is what they had as your options for your conclusion. Okay. Oh, need that bigger. So we're gonna together, if that makes sense, we're gonna determine which one is the correct one. All right. This is what you guys are doing, right? Population, spelled that one. I'm gonna move that. Okay. This is multiple choice, right? This is not number one, but it's, you know, where I'm thus the final conclusion is that blah. Which one is it? So let's see. The data suggests that, okay, the population proportion is significantly larger. Now, a lot of times I like to stop there and determine if that part is correct or not. You tell me. You know, the fact that we're saying is significantly larger than 16. This one is, this is not, is not.
It's A for the first one.
Yeah. I mean, it's funny because just based on that, we could determine which one it is, right? Because we're supporting that it's bigger. So all these that say is not significantly larger is not, I mean, I'm going to get rid of them. But let's just double check. It is significantly larger than 60% at that alpha. That's our significance level. So there is sufficient evidence to conclude that the population proportion of inner city residents who have sleep apnea is larger than 60%. That matches what we said. So this is my answer for that part. Yeah. This one has this particular question. I think this is number one that I picked, but this has something extra for interpretation. Is it this one? Yeah. Interpret the level of significance. So I'm just going to bring that here. So this one also says interpret. Now I'm going, I guess, a little bit backwards because I want you to interpret the level of significance before you interpret the p-value, so that I guess it helps make it a little more clear. Now, the level of significance, wait. Where is it? Interpret the level of significance. Sorry, I don't know why. There we go. Your significance level is your Your significance level, I'm trying to delete that. Your significance level is your probability of a type 1 error. So your significance level, which is alpha, which is in this case 10%, 0.10, is the probability of a type 1 error. And could we have a potential type 1 error for this particular example?
Yes.
Because we rejected the null. But look, type 1 error is rejecting the null when it's true. So you tell me what that means then to you. Like if we made a type 1 error, what does that mean in your own words? So, okay. You told me that I rejected the null, which means that I'm claiming that we're supporting the claim that a higher percentage of those who live in the inner city have sleep apnea, right? More than 16%. If I made an error and I was wrong, there are things that I could do to maybe change my outcome, which is true, Angela. I could potentially do stuff to change my outcome, but I'm just trying to interpret it. So if I made an error, then I'm wrong, and inner city does not make sleep apnea greater than 16%. So let me see what I have here. Let's see what we have as a choice. Now I could do stuff to change my outcome, but you guys don't have to deal with that. You could, if you want to, play with that outside or look at different examples in real life scenario, which is what people do for FDA approval. They have to change the outcome. They have to increase their sample size. There's a lot of stuff that happens if the outcome is not what you want. But we're not going there. We're just trying to interpret. I'm honestly going to say process of elimination. There is a 10% chance that aliens have secretly taken over the Earth. Okay, that's probably not true. Yo, I didn't even put that there. Okay, that was probably just there for fun. That's hilarious. Wait, and have cleverly disguised themselves as the presidents of each of the countries on Earth. Oh man, that's funny. Okay. Could be true. I don't know. All right. There is a 10%. I'm going to the small ones first because I'm assuming they're wrong, by the way. When you guys have these multiple choice of level of significance and then I'll do p-value, it's highly possible it's the longer ones. But let's see. There's a 10% chance that the proportion of all inner cities who have sleep apnea is larger than 16%. This is not the right way to say that. No. Okay, let's look at this. If the population proportion of inner city residents who have sleep apnea is 16%. Now, if the population, I don't like that. Why? Because it says is 16%. This is matching the null hypothesis. If the population proportion of inner city residents who have sleep apnea is 16%, I mean, we rejected the null. So I'm going to assume that this is wrong. I'll double check, but I'm going to go here and see if this matches what I'm thinking. If the population proportion of inner city residents who have sleep apnea is larger than 16%, that matches my alternative. And if another 347 inner city residents are surveyed, then there would be a 10% chance that we would end up falsely concluding that the proportion of all inner city residents who have sleep apnea is equal to 16%. Ooh. Now, I don't like that either. So I'm going to go back to this one. Why don't I like that? So type 1 error is rejecting the null when it is true. And this one says, falsely concluding that the proportion of all inner city residents who have sleep apnea is equal to 16%. I didn't falsely conclude that. I didn't conclude that at all. I rejected that. This is not matching our situation. Notice how, like, that's probably what makes these confusing, because it's literally these little words that change the whole thing. Remember I said this didn't match my alternative, so I didn't like it, but I didn't finish it where this might be my actual answer. If the population proportion of inner city residents who have sleep apnea is 16%, this is supporting the null hypothesis. This is going along with that. And if another 347 inner city residents are surveyed, then there would be a 10% chance that we would end up falsely concluding that the proportion of all inner city residents who have sleep apnea is larger than 16. We're rejecting the null when it is true. We're throwing away the null. We're supporting the alternative. And you guys told me the alternative said that sleep apnea for those inner city residents is bigger than 16. We falsely concluded that if we made a type 1 error. And if I'm concluding this and it's wrong, then it should be equal to. And so I'm going with A. Let me pause for a second on that one, and you guys let me know if that makes sense. You might have to read it a couple of times. Obviously B's out and D is out. It's always going to be one of the larger ones. It's now a matter of which one of these matches what you basically concluded. And I did skip this one first because the first part of it was the null. But technically, if I'm doing a type 1 error and I'm rejecting the null when it is true, I'm falsely concluding the alternative. I hope that makes sense. I hope that makes sense. Because now you're going to be asked about the p-value. And really, you know, these are repetitive kind of things because obviously, where is it? Obviously, there's going to be repetition, given that the conclusions are going to be worded in a similar fashion, if that makes sense. It's going to vary depending on your obvious situation, and it's going to depend on your conclusion, right? Because if we failed to reject the null, then I would have a type 2 potential error. But we rejected the null, so we had a type 1. This is why when I'm interpreting some of this stuff, I have, you know, my interpretations in front of me, if that makes sense. Interpret the p-value. So I'm going to go ahead and say, basically, that these two are they're the smaller ones most likely out, right? But there's a 0.52. So by the way, where's the p-value? P-value is 0.0052. Let me write that down here. P-value, right? So it's an area, which means it's an also percentage, okay? And the p-value is a probability that you will see a test statistic as extreme or more extreme as the one calculated when the null hypothesis is true. Okay, when the null hypothesis is true. So let's see what matches that. Now, it's not a chance of a type 1 error. I said that's alpha, so that's out. There's a 0.52% chance that more than 16%. It's not as simple as that. Now, let's look at the two that are possible, and we have to get rid of the one that, you know, is wrong. And really, if you notice, a lot of this stuff is very similar. This says if the population proportion, this is if the sample proportion. So off the bat, there's something that varies, okay? Just like here, you know, these little words change things. So let's see what the rest of it says. If the population proportion of inner city residents who have sleep apnea is 16%, so this is matching the null hypothesis, right? And actually, I'll write it down here too. The null hypothesis was this, and the alternative was that. Sometimes it makes it easier to have that in front of us too. But remember that the probability that you will see a test statistic as extreme or more extreme as the one calculated when the null hypothesis is true. When the null hypothesis is true. So right now I'm looking at A, because this is right now following the null hypothesis. The population proportion of inner city residents who have sleep apnea is 16%. That's the null. And if another 347 inner city residents are surveyed, then there would be a 0.52% chance that more than 21% of the 347 inner city residents surveyed have sleep apnea. Where'd they get the 21%? Uh-oh, did I copy the wrong one? Oh, let me go back. P hat was 21%. So let's write that down too. P hat was 0.2104. So, which is approximately 21%, right? Okay. Okay, so there's a lot of stuff thrown around. The 16% corresponds to my null hypothesis. The 52.52% corresponds to my p-value. And again, my p-value is a probability that you will see a test statistic as extreme or more extreme. So as extreme as what we have or more extreme as the one calculated, but when the null hypothesis is true. If the null hypothesis is true, which is what we kind of want, and if another 347 inner city residents are surveyed, then there would be this percentage chance that more than this, more than what's happening with the sample statistics of the 347 inner city residents would have sleep apnea. I don't know about you, but that sounds like it's corresponding to this as extreme or more extreme as the one calculated when the null hypothesis is true. But let's read this one and see if it makes sense. Now the thing is, if the sample proportion of inner city residents who have sleep apnea is 21%, that doesn't match the null hypothesis, you know, and 21%, we're talking about the sample proportion. So if the sample is 21%, and if another 347 inner city residents are surveyed, I mean, that doesn't make sense because it's not corresponding to the definition of a p-value. So technically, this one was not easy. I'm not difficult also to kind of eliminate the one that doesn't make sense. And this one is A. Now, again, you're going to practice this to the point where it's going to be repetitive because you're going to see a lot of the same verbiage. But you can see too, because it's multiple choice, your life is a little bit easier because you could just get rid of the stuff that you know is wrong. And that is what I suggest you do for these to basically help, you know, with selecting the correct answer. Okay, so, you know, when you're interpreting level of significance, you're talking about a type 1 error, rejecting the null when it is true. And sometimes I like having the null there also. And then the p-value is a little bit more difficult, I think, to interpret, but it's a probability that you will see your situation as extreme or more extreme as what's happening in the sample when the null hypothesis is true. So if it doesn't correspond to that, then that's not the one. If this question didn't ask, actually, this question didn't ask me for critical values, but you know what? Let's do it just because. And critical value is not difficult to find, but you already told me it's a right tail test. So my rejection region is in the right tail. Alpha is 0.10. So the area that's in the rejection region, do I know that value? How much is this area here? Do I know this area? If I want to find the critical value, do I know the area?
Is that the 2.560?
That's your alpha. So, right? When you talk about rejection region, critical region, you see I always write alpha as that area. Well, if it's two-tailed, alpha over 2. So this is my alpha, which is given as 0.10. Now, I don't know if you went ahead of me. I didn't find the critical value, but I don't have to do alpha over 2 for this because it's a one-tailed test. So all of alpha goes into one tail. If it were two-tailed, then I would cut it in half. Now, if I know this area, how do I find this critical value? All right, forget it. Let's go here. You tell me. If I want to find a critical value and I'm doing a proportion, then I should use inverse norm. All right, so let's do that together. You guys are home doing your stuff. Let's go here. You go to inverse norm, which you know is in second vars. And you're here, area. What do you put? Some of you have the app, some of you don't. What do you put for yourself? You tell me what you have and what would you put? You don't have to be right. You're not in a test right now. We're practicing this independently, right? So pretend you're independent, right? What's the area you put here?
0.10.
You could put 0.10. Do you have this option?
Oh, so I would have to do the 1 minus E99 first, and then 0.10?
Well, you know what? Watch this. I'm gonna put 0.10, right? Do I change the mean and the standard deviation here?
No.
Now, if you don't have this option, so let's assume this is not here, okay? Because it's automatically area in the left if you don't have that. You got negative. Does it make sense that it should be negative if it's a right tail test?
No, so it would be the same answer, just take off the negative.
Yep. So you could do it that way if you want to. Yeah, you could do it that way. And then if you guys have the option to tell it where the area is, oops, you could tell it the area is in the right tail, and then it'll give you the positive version. But it's a symmetric curve. You don't necessarily have to, right? But if you're going the route where you're not telling it where the area is, or doing the 1 minus, this is why we did the 1 minus stuff, because it would tell it the area to the left, because it's the complement of the area to the right. But at the end of the day, it's the same value, just make sure it makes sense. If it's a right-tailed test, the critical value is positive. Don't do it to the test statistic, the critical value. And if it's a left-tailed test, you know. So at the end of the day, when I go to my test statistic, which was what, where the heck is it? This, 2.56. My test statistic was 2.56, which is bigger than this. And by the way, if I want to represent the rejection region, I would say Z 1.28. What would I put here? A 1.2816, I meant. Where's the rejection region compared to the critical value? Is it to the right, to the left? Where is it? To the, yeah, to the right, right? So this is how it was last week when they asked you where the rejection region was. It was always compared to the critical value. They didn't directly ask you for the critical value. They represented it this way. But your rejection region is anything bigger than this critical value because it's a right-tailed test. And your Z-score, your test statistic, particularly, is greater than that, which means that it's in the rejection region and you would reject the null. But then we already knew that. but that's if they make you go through the traditional method, right?